In this video series, I'll demonstrate for you end-to-end polycarbonate part design, structural optimization for 3D printing, and maybe install of the part, maybe not. Obviously this recording is not live, so that video is not live, but you could probably find it on my channel if you're curious to see it printing out. That's if it succeeds. I say that because this spool of polycarbonate is quite, I almost want to say it's haunted. So all inventions, even the simplest, are to solve a problem. Today's minor problem: I was feeding my cat Godzilla, and I gently bumped my head on the barbell, and that's near where Godzilla eats. So I feed Godzilla on some shelving that keeps his food up and out of the way of his fur brother, my dog Deke. And so next to these shelves is my little exercise center, which is basically a power rack, squat rack type of deal. And there's a Olympic barbell up on there. It's a very long bar, 45 pounds, and it's got storage hooks for that in the rack. But no matter which hooks, where I position the hooks, the barbell always seems to be in the way. And I'd like to store it up higher than my head, then it would be out of the way. But the hooks don't go that high in the rack. Even though the rack goes high enough, the holes in the rack don't go high enough. And so I decided that if I had some hooks up high, then I could store the barbell up above my head, and then it would never be in my way. And I'm not going to have any weights on it when it's up there, so it only has to hold 45 pounds reliably. I'm likely just about never going to be under it, so it's not really a safety issue, although I'm going to make the hooks out of polycarbonate and do a little bit of structural optimization just to make sure they're way overkill strong and I'll never have to worry about it. And so I'm going to share with you my process of doing something like this. And so I'm going to design it in Solidworks here. And if you are a Solidworks interested in learning about Solidworks, I do have, as you can, I think you can see, my keyboard and mouse overlay here. And a lot of my shortcuts here, though, are not, my hotkeys are not the standard hotkeys. And I do recommend that anybody use my hotkeys. I've developed them over, I don't know, well over 10 years of using SolidWorks, probably closer to 15 years using SolidWorks, and have my ways that I like to do things. So anyway, I want the XZ plane. This is a new template that I'm using because I got sick of my quirks of my old template. So okay, well, it's called the top plane. I'm going to call this the front plane. I'll have to rename the front plane then to not be front plane. So let's just call this what it is, and it's going to be XY, and the front plane is going to be XZ, as they should be named. Caps lock, thank you. And this one would be YZ. Alright, that makes a whole lot more sense to me. Okay, so XZ plane. I should save this as a template before I forget, but I'll do that later. So I'm gonna put a rectangle on this plane, and so I can do that. I can initiate a sketch by just doing any sketch command. So I select the plane, Control R for rectangle. And it still does that goofy thing where the icon is upside down. Whatever. So that's why I started a new thing, so it wouldn't do that, but so much for that. So now I changed the way I was doing this. So now when I select these, you should see my little sub menu pop up. Yes. Okay, so now I'm going to make these equal, and I'm going to call this 2 inches. I already measured this. I hope this is not in metric. I'm pretty sure it's not. Okay, so 2-inch square tubing is the cross member, and then the barbell is C for a circle, and that's 1.1 diameter. Now, ideally, the bar would be under the cross member, but the bar is longer than the cross member, and so the vertical legs of the rack would be in the way of the barbell, so I can't do that. So I'm going to call this, I'm going to change this to the minimum number. So rather than to the center, I could go maximum, I could go minimum. I could go center. I'm going to go minimum. And let's just, for the sake of putting some number in there, I'm debating, so do I want it to be rigid, or do I want it to be allowed to flex until the bar hits the steel? That actually may be a good way to do it. And actually, as I think about it, I could actually put a little bit of plastic between the barbell and the steel. Yeah, that's what I'm going to do. Actually, that will make it even stronger. Okay, so this is how you design things. You have a vision in your head, you start to lay it out, and then you improve on it. And it's funny, I work with clients doing design work for them, and I've learned over the years that people don't realize how much iteration there is in the design process, and that's part. A good designer should be able to design something quickly and have it be perfect. No. You buy a BMW, you buy a 1982 BMW car, and it's nowhere near as advanced as the newest, right? Because even the biggest organizations are constantly iterating, coming up with better and better technology. So I'm going to call this a 1/4 inch. Probably overkill, and I'm fine with that. All right, now, how much lower does this need to be? Really not much lower. And I'm going to make this minimum. I'm going to click on the liters tab, and I'm going to say minimum. I don't know I don't know why it's under a tab called liters, because there's no liters involved. Anyway, a liter is more like this, which a line with an arrow and annotation. This is technically not a liter. Interestingly, I'm not using. This is not by the ANSI standard because it's a blank template, but that's fine. I'm not making a drawing. And so I'm going to make this number. I guess I can put it as high as I want. Although I'm looking at the rack and there are a couple bolts there that could be in my way. I guess I should measure those. I'm just going to position it arbitrarily. No, you know what? I'm gonna go measure this right now, and I will be right back. All right, so I just took a couple measurements, and I'm going to neglect this dimension for now, and I am just going to say that I'm going to offset this line, not the chain, 2.25. That is the distance to the top quadrant of the bolt in question. So I'm just going to drag this arbitrarily for now, just to get this out of the way. And there's also another bolt at the center. Oops, at the center here. So it's funny that what I've envisioned in my head when I designed this morning, mentally, was almost entirely different than not entirely different. It was very primitive compared to what I have in my mind now after looking for it for 5 or 10 minutes. And so I was going to have this sort of, I was going to have this sort of probably hanging down a little further, and hadn't thought too much about how far. But now that I look at it, I can really store this up pretty high. So but basically there's going to be, this is not going to look circular in this view, but it'll be useful enough. So there's basically a bolt here, and a bolted connection here. So screw nut washer, and the outside diameter of that washer is, let me look at my verniers here, looks like 0.78. And so I'm going to select both of these, and then I'm going to call them equal. So then I dimension this once, and I call it 0.78. And so now I know I need to be above this and below this with the actual bar. And the higher I put it, the more structurally stable I can make it. So, because I did this minimum number, and that's fine. I'm just going to call that good enough. Now keep in mind there's also a line here, and for that matter here, which is sort of irrelevant, so I'm going to leave it out. I'm going to fix this just because there's probably people having an aneurysm because I don't have fully defined dimensions. I think that's can be important, and especially if you're trying to be a dictator in your engineering department, it's nice to have rules because then you can feel powerful. But I've seen plenty of competent design engineers. Because I remember I was taught that, and then I went to a place and worked with a guy who was a much better designer than me, and he had this curve in space and it was all blue, and I was like, well, but it's not fully defined. He's like, sure it is. It's in that sketch. That's what it is. The perils of creating tutorial videos. Evidently, I had at some point made hotkeys to start and stop recording in OBS, and so I just did a bunch of work that I didn't record, and so I just deleted it all again, and I got rid of those shortcut keys, and so here we go. So forgive me if you've already seen some of this. I'll probably edit that out. So this started like this. Whoa. I didn't even have the extrude feature yet. Back in here. And this was not yet construction. Alright, so here's the cross-member tube. And this represents the barbell bar. And this represents the vertical leg of the power rack. And so I'm going to just select this and offset by 20 thousandths of an inch, yes, and make this construction, and I'm going to offset this also by 20 thousandths of an inch and make this construction, and I just know that I'm going to put a line like this, and then I'm going to do a tangent like this, and tangent like this, and tangent like this to here. Not to there. If I undo it, does it do it? No. Okay, good. Alt A for tangent arc. It's going to be like to here-ish. It's really going to be tangent. It's really going to be tangent to this guy. Tangent. And let's extend this down. Let's extend this, trim this, and it's already tangent. Okay. And so this is obviously exaggerated, but that's fine. And then we're also going to create a line from here, and it's going to be automatically tangent. Whoa, unless I broke it. So this should be automatically tangent, and something like this, and then again tangent, something like this. And then again tangent, something like. Now this is risky, doing multiple tangent curves. That can bite you, but I have a plan that I just came up with that I've probably done before, but not this efficiently. And this is going to be tangent. And so basically I'm going to make a line here so I can define this angle. And that should keep me out of trouble. If I didn't have this line here, this could get very unwieldy. But so I'm going to take this line and give this a dimension of, say, I don't know, 5 degrees. And this line is already straight, and so I'm going to call this also 5 degrees, just arbitrarily, and I can adjust those later if I want. And let's move this upwards. Can I? There we go. There we go. Now there's going to be a potentially stress riser here and here, but that's why I'm making this big radius. We'll see how that plays out when I throw some FEA at it. I need to make these construction. Select chain, construction. And I know I already did that. I already undid that and then redid it. That's fine. There's a radius here. I'm going to put a radius in here, but it's a very small radius on the square tubing. I'll put that in as a next feature, just because it'll be simpler that way. I've heard people, again, self-appointed dictators say, you have to do the fillet not in the sketch. And I call BS on that. It's all situational. So many people are so definitive on things that are, in fact, in my opinion, situational. And I've been doing this a long time. Let's undo that. So I decided that I want this. So this hook is going to want to tape, but going to want to flex, right? And so that's why it's sort of exaggerated like this. I want it thicker. The further it goes up the hook, the thicker it needs to be, and the further to the tip of the hook, the thinner it needs to be. So how can I accomplish that? And I already know the answer, but I'm just saying it for your sake. So I'm going to create a line here to here. Then I'm going to make it coincident with this. And then I'm going to create a line from this midpoint just to an arbitrarily reliable point. Let's say to here, and then coincident again with the center. Did I just accidentally call it a midpoint? No, good. And again, let's say from here to here, and then coincident with the center point. Did I stay record? I did. Good. You get punchy when you do stuff, and then it wasn't recording. Let's drag this guy more like this, and just because it's easy, let's make another line here to here. So now we want this line to be longer than this line to be longer than this line, and this one also, but less important. And the reason for that is that the further out you go on this, the stress concentrations are going to reduce. The maximum stress is, well, not the maximum stress, the maximum localized stress, like on this line, is going to be less than on this line, is going to be less than on this line if they're all the same length. I might have said that incorrectly, but maybe you get the basic idea. So, so let's say that this, and I'm going to just make this a driven number because I'm not trying to drive it with this, but let's say okay, and then let's right click on it, escape out of it, right click, driven, and so now that can be whatever. But then I'm going to, first I'm going to save my work here, S for save. It's Control S is the default hotkey for save, but I like to save even more easily and often, and so I just made it S. And so my spline is Control S. So I flipped those shortcut keys. Now I want this guy to be, so I just want that to be very not vertical, so it's obvious that I'm not doing a vertical dimension, because you don't want to accidentally do a vertical dimension if it's not necessarily vertical. Oh, jeez, damn it, I did it. I want to make sure it's not vertical, and so I do it this way. And now this is going to be a formula. It's going to be equals this times, let's say just arbitrarily, 0.75. But I have a better way of doing that. So I have a more customizable way of doing that. So I want to create this line here. And I'm going to call this 0.75. I'm sorry, 0.25. Just because I think I'm going to do increments. This is going to be smaller than this. This is going to be smaller than this. This is going to be smaller than that. And so I'm going to use this as a multiplier. And so I'm going to edit this to, rather than saying 0.75, I'm going to say times this times 3. And I'm going to copy this, Control C, and I'm going to say OK. And then this is going to be also a formula. And I'm going to paste that, but then I'm going to call this times 0.2. I'm sorry, times 2. Ah, that got ugly quick. Got ugly quick. And you know what I'm going to do? I'm just going to delete that. And I'm going to trim this, and this, and this. And I want to make this tangent. Problem solved. Let's put this line here. So evidently, I didn't want that straight line in there. It was just going to cause me a little bit of hassle. And I see that I don't have an angle dimension here yet. Kind of thinking I already did, but again, I did that work that I didn't save. I'm sorry that I not that I didn't save it. I deleted it. Why is this? Okay, well this doesn't. That one's not happy. I'm not sure what the deal is. That's fine. So now the reason I did this is, in theory, now if I adjust this scale factor, say 0.23, that will adjust the proportionality of this line to this line to this line, right? So that's interesting there. Anyway, we now have mostly good geometry. I need to trim this, and also here. Otherwise, it would not have looked right. And so now I'm just going to X for extrude, and let's call that 3 inches. Enter. So now we have this. I want to put a dimension on this radius, tip radius here. 0.06, which should be good. And that's obviously arbitrary. And oh yeah, I want to put fillet in this corner. U is my fillet command, and Alt U is my sketch fillet command. And I want to call this 0.06. I hope that's not too much. I don't think it is. The radius is pretty small on the tubing, so I obviously don't want it to be too large of a radius, then it would cause a bad situation. Alrighty. And so the I made this 3 inches, but the tube is 2 inches, and so I am going to just create a sketch here and create a rectangle, and it's going to be 2 inches from here, and it's going to be in line with this. Am I thinking about that correctly? I'm just going to do it, and then when it's wrong, I'll change it. I also need to go this direction slightly. I can drag this down to almost nothing, just to get rid of that radius also, right? So now, yeah, so I totally thought about that backwards, and so I'm still going to reuse the sketch. I'm going to delete. No, you know what? I don't even need to delete that. I can do this. I can do this, and then I am going to for rebuild, and I just need to go the other direction. So flip that direction, and then I'm good. Except for oh, I don't want the second direction. Is that what the deal is? It seems like that's going to miss something. Something about the radius. What happens to the radius if I do that? Yeah, so I took away the radius by doing that. I don't want to take away the radius by doing that. Okay, so I'm just going to alright, I'm just going to delete that. Oh, I can't do that. Oh, because I made the sketch relation collinear with the edge of that fillet. So if I just select this and I say collinear delete, now can I do that now? Now it lets me do that. Good. And so I lost the relation to that, but it's probably not going to be a problem. Yeah, it's not a problem. It's, in fact, it needs to go away, so I can do that. There we go. I'm going to put a little radius on here just because while I'm thinking of it. So this is ultimately the shape that I want, although very not optimized. So as you can see here, if it's not obvious, and I'm just going to show so let's put a sketch here, and no, I'm just going to reuse this sketch. I think I should be able to select. I need to show the sketch first, though. Show the sketch, N for normal to the selection, and And I'm going to reuse the sketch. I'm going to say X for extrude. And I'm going to say select contours. And select these. It doesn't want me to select that contour. So I guess I'm just going to, in fact, create a new sketch. Oops, create a new sketch here. And create a new rectangle and use these as a reference. And direction 2 up to here. And don't merge. And then let's say like this. And not in the midpoint. What are the chances of getting that? And like this, and do this, and then call these equal, so it's a square. And then, so let's say that, and control that, and collinear. And now I have my vertical cross member just for reference. And then I can also do this just to represent the barbell. I'm just going to project this geometry. Don't merge. Direction 2. Done. Okay, so now one more. I'm just going to change some color here to make this easier to see if it's not already. And let's go clear plastic just for the visual. And apply that to... evidently I did a merge bodies. So one of these extrudes, probably the middle one, I forgot to uncheck the merge. Sure enough, the middle one. Okay, and copy that appearance, paste the appearance here on this body, and then remove this appearance. Okay, so now you can see how this hook will hook over the cross member, but then it will use the vertical member to support the to give a lot of extra support to the hook here. And I mean, looking at this, I already know if I make this a polycarbonate, it's going to be so much stronger than it needs to be. And I can even make this a lot less tall. Save myself some material. Which way is it? I was afraid of something like that. So let's see. Let's back up to here. And okay. I'm just going to do this. I'm going to call it 2. And so the sort of error is in how I defined this sketch. Because I defined it right to that edge. Wait a minute, what is going on here? Yeah, so this is my overlap. So let's call it 1 inch. So now it's halfway. And then I'm going to roll to end. And so this is probably fine. It's probably still overkill. Actually, though, you know what? I really want it to lock past the other side. I'm going to undo a couple times here. Get back to where I was. Now I'm back to where I was. And I'm going to move face on this. Let's call it 0.05 just for good enough. And then I'm going to create a sketch on there and project that geometry. And just a little bit of an overhang. So it will catch itself on the other side of the Yeah, that's what I want. So it'll catch itself on the other side. And let's make this tangent. In fact, I don't know, just for the fun of it, I'm going to put my radius in the sketch and show that the world doesn't come to an end because of it. So the question is, how much overhang do I think I can get away with here without supports? I really don't want to put supports. I think this overhang probably fine. Just thinking. Just debating how I want to do this. All right, let's call this good enough. And cause I want to put a little bit of a taper to make the overhang more reliable. So I'm going to extrude this another, say, 0.13, eighth of an inch. Merge only with this. And I'm going to taper this. I kind of don't like that. That's a little bit about it. I'm going to adjust this. I'm going to adjust this to, yeah, okay. Let's do that. I'm going to get rid of it in a second, but just so I can extend to there, trim that, and let's just make a line tangent to that. And then trim this, interesting. I'm going to trim that. Trim both of those. And I'm going to do a tangent. I'm going to do a tangent arc. Like so. Make a tangent. Well, first I'll trim this. Trim. Did I miss the T? T for trim. And then I'll select these, make them tangent. Hope I'm still recording. Looks like I am. And so I don't need this to overlap a whole lot. I just want it to overlap a little bit to act as a catch so the hook doesn't slide inboard. Right? Does that make sense the way I say that? And R for rebuild gets me out of there. But I want to taper that. And so, I got rid of my top flat surface there. So I'll just go to, say, here. And then I'm going to go normal. And it's a bigger gap visually. That's only 50,000 though. Whatever it looks like, it's only 50,000ths of an inch. And let's go, say, 45 degrees. I'm not sure why this still didn't snap to that, but that's fine. Let's call this, if I control A, yeah, okay, so this blue for some reason is in a different sketch. Or is that a plane? It's a plane, I guess. I don't know. Don't care. Don't care. Let's call this 45. You could probably get away with less easily, but this will be fine. And extrude that away. Extrude cut. And now I have a sharp edge here, so let's throw a little radius on this edge. And why can I not select that edge? Okay, now I can. Not sure why. You fill it. And before I do that, let's extrude cut in both directions. There we go. Now you fulfill it. No. Oh, actually, sure. That's fine. I was going to do that anyway. So this being transparent, it's tricky to see. So now you can see what's going on here. I want to put another radius I'm going to right click and isolate this. Yeah. And I'm going to remove this. Actually, you know what? I'm going to do another display state so I can go back to transparent if I want. And in this state, I'm going to, if I delete that and then I go back to here. Okay, yeah, that's what I want to do. Okay. What? Somehow it got me out of isolate and lost my, getting rid of that. I do want to isolate this again. You know what I could do instead of isolate is just do a delete keep bodies, keep this, enter, and then I can suppress. I can just suppress the. I can just suppress that, unsuppress it as I wish. Hide my sketches, which is the asterisk numpad asterisk on my shortcuts. And is this going to do anything? This nub? I think I want that extrude to go a little taller so that the nub protrudes more. And evidently I broke it. Instant 3D is very useful often, except I broke it. I'm sure I just made a intersection here that I need to correct. Yeah. So let's do this. Just drag that out and we're good. Okay. And this radius, I think I can get away with just adding this here. Yes. Looking good. I'm tempted to put a radius here, but it's not going to really print as a radius, but it'll be good enough. And so I am going to. And yeah, that'll be fine. I'm going to use a brim anyway, and then scrape the brim away. So that's the basic shape, and I'm actually pretty confident that this should be plenty strong enough, really. But we'll see. All right, and so this is actually, I'm going to do something that I don't typically do, is do finite element analysis on plastics because it's not reliable. So I never offer it as a service to clients generally. Excuse me. It just doesn't generally come up. But this is an interesting case, and I'm going to do it. And I'm going to sort of explore my own technique that I've had in my head for a long time and just never bothered to try. So I am going to add in my simulation. So now I can do structural analysis on this. But being plastic, it's not really going to be reliable. But that doesn't matter. I am going to ask Google off screen here the properties of. Why can't I? Okay, fine, be like that. I'll just move to the other screen. Let's ask Google the. I guess I'll just go to MatWeb. MatWeb.com. Polycarbonate. And it's obviously going to be somewhat, at least somewhat degraded, being that it's 3D printed. Although, I don't know why I didn't like that. I'll just actually go to matweb.com. And I'll bring this over here for you guys. Whoa. Totally uncool. Okay, I am recording again. All right, so here we have matweb.com on screen. Great resource. And let's say polycarbonate, just to get a rough idea of the mechanical properties. Overview of polycarbonate ABS. No. Polycarbonate. I mean, let's just say extruded, just to look at something to get, and I'm going to degrade it so many different ways because it's not going to be accurate, but at least it'll show me where my stress risers are. That's really all I want. And mechanical properties, hardness, tensile, ultimate yield, good. All right, so the yield strength is 5 to 10 KSI. KSI is 1,000 PSI. Just kind of engineering slang. So now if I did it, well, actually, I wonder if I tell it it's polycarbonate, it's probably already in there. Let's see. That's probably, let's see what ABS PC says for properties, just to compare it to my MatWeb. Let's go to Imperial Units. And it is saying my yield strength. It does not list the yield strength. That's fine. And it doesn't list the. Okay, it does list the tensile strength. Okay. 58. What's MatWeb saying? Ultimate tensile strength 4 to 10 KSI. Interesting. It's the same as the. Yeah, anyway, I'm not going to try to pretend I'm an expert at nonlinear FEA because I'm not. I've done tons of metal static structural FEA, but not plastics. Not professionally. So, so tensile 5. I'm just going to call it 4,000. And it doesn't want to let me edit that. I seem to recall, hopefully this was on my old install, if I made a copy of a material and made a custom material that it wasn't saving in. Custom plastic. Alright, well anyway, let's paste this here. Can I do that? Alright. And I'm going to call this J because it's my initial. So I know that it's my version of it. And so now, okay, now I can edit these. Good. So I'm going to call this 4,000 just to be on the safe side. I'm going to call this 2,000 just to be on the safe side. And I'll still take it with a grain of salt. Does it show me the Poisson ratio? Not sure how much that really matters. I don't see it if I search for it. No. I'm guessing it's probably less than for a metal. Oops. So let's, because there's not going to be one in here. Oh, it shows a number. Okay, that's probably a reliable number then. I remember a lot of times when I was looking to build my own materials, that was always tricky to find. But so nice to see that it's in here. Apply button. I don't know if that's doing anything. I'm going to add this to my favorites, and I have a feeling that that's not going to work. Although evidently it did. And evidently that worked. Good. Okay. Now, I'm going to add a study and analysis preparation. No. Evaluate? No. I did add the. Didn't I just add in the add-in? Evidently not. Could have sworn I did. Simulation. Okay. For some reason it didn't take the first try. I'm sure it was my mistake. So now I need to welcome to the FEA portion of the video. Actually, let me stop and start because I might make this separate portions. Alright, so now let's do the structural analysis. So I just did tools, add-ins, and added the simulation add-in. And I already made the material, a weakened version of the ABS PC I don't know why it's ABS PC, because let me think about that. Let's see. Is there just a regular PC? I suspected a long time that whenever I selected ABS PC, probably because there was not a simple polycarbonate. Let's see. Plastics. ABS PC. See all these letter combinations. I don't see just a PC. But anyway, the MatWeb info is not ABS PC here that I selected. It's just PC. And so, and I've derated from there significantly. And so we'll call this good enough. All right, so let's go to simulation, study. I don't need to name it. We'll just call it static 1. And my material, because I pre-selected my material, it's already established. And okay, I'm going to go back into my model. So what I need to do is first I need to define my fixtures, meaning what's holding this in position. And then I need to define my external loads, which is sort of pushed down on here. And then I need to build a mesh and then run the simulation. But, so first things first, for my fixtures, so I basically want to add a sliding fixture here, but it's not across this whole thing because it's only from here to the left. So I'm going to do a split face on that. I'm going to go back into the model, and I'm going to put a sketch here, and I'm going to put a, I'm just going to project this line, and I'm going to do this little trick that I do, create a circle, extend the line, trim the circle. So now I have a nice long line, and then I go split line. I split this face. Done. Okay. So now I can put a sliding support there. Now the tricky thing about something like this is I have to select something that's immovable. And it's really, in reality, none of it is immovable. And so there's different ways of doing that. And just for the sake of this, I am going to say that this is immovable. So when I go to fixtures, I could say fixed, I could say roller slider, fixed hinge, elastic, blah, blah, blah. One of them, in my understanding, and please somebody tell me if I'm wrong, because I believe this is how it goes, unfortunately, is that something has to be fixed. So I like to select something that's like out of the way and weak and call it fixed, and then do sliding supports elsewhere. It can give erroneous results, but this is what I find works for me. I'm going to call that fixed, and then I'm going to add another fixture for roller slider, and that is going to be this guy. Right? And then I'm going to do another roller slider for this guy. Remember I did that split face for this. And it's really going to try to slide off. And so I'm going to make another roller slider just for that point right there. I'm not sure how that's going to work out. Again, this is not for something professional that I'm doing. It's just, in my experience, how I can get good enough results to get a rough order of magnitude prediction of where the stress risers will be. Can I do to just a point? I can't do a slider to just a point. So, all right, let's call it this line then. I can't do it for just a line? Man. I guess I need to do another split face. Go back into the model. Sketch here. Line here. Call it horizontal. Oops, that's in this view, that is vertical, even though it's not really. I'm going to do a dimension from here to here. Why did that not take dimension to here? Okay, that was weird. Say 30 thousandths just for something. And then a split face, split line, this face, what? I don't know why all that's highlighted, but anyway, I only selected the one face. Oh, what? I don't understand. Okay, I don't know why, I'm not sure what happened there, but that's fine. So now I have this little face here, and I'm going to make a slider out of that. And that will sort of allow this to sort of spread this sort of this to sort of spread as I think it would tend to do. Let's see what happens here. Back into my analysis simulation and add another sliding fixture. No, that's fixed. Roller slider. And like I said, there may be a better way to do this. I'm not a total FEA guru. I just know enough to get what I want done, and I'm on the wrong face. Just enough to get close enough. And I tell you what, you might say, oh, that's not the right way to do it. I'll tell you one thing. I've designed spacecraft structural components using methods like this, and then independently verified from an independent lab who did fatigue and modal analysis on entire assemblies and all the parts. And my assumptions work for the most part. So feel free to roast me. I've had my methods verified by legit aerospace independent structural lab analysis to evaluate and honed these techniques to successfully pass very consistently. So there. Nah. Okay. I'm mature, I know. Alright, so I'm going to save my work because it's usually crash right before you save your work. I was going to put some kind of taper on this, but that was before I was going to back it up by this vertical tube leg and that. So this thing is going to be so overkill anyway. But it'll be interesting to see how it flexes. Alright, so now I need to put a load on it. And there's a lot of different ways you can do that. And I'm going to do it the wrong way that works for me again. I'm going to put a sketch here, probably the wrong place to put a sketch. Please roast me in the comments. I mean, I've only been doing this for over 25 years, so feel free to roast me. And I'm going to split line. I'm doing this from in the analysis, which sometimes can bite me, but I'm going to say maybe it won't this time. Alright, this is a little off center, so let's just why? Oh, let's adjust this sketch. I'm going to go normal to it, and I'm going to create a line from the midpoint of this to the midpoint of this, and then make it vertical, and that will do that. And then I'm going to put a dimension here, just to call this 0.06, just to give it a number. And okay, so now it's much more representative. So as long as this doesn't deflect, this is really fairly representative of what's going to happen there. And what I mean by that is I'm going to apply my load to that sort of fat line. Again, in my experience, sufficiently. I heard an interesting quote, and it's funny, there's always a know-it-all that will tell you that you're wrong. And okay, and I know I'm wrong a lot. But a great quote, and I quoted it somewhere else, and then somebody said, "Oh yeah, that's such a great quote," and I thought it was funny because somebody who's a legit smart person berated me one time for saying that doesn't make sense. All models are wrong. Some models are useful, and that might be a paraphrase rather than a quote. I don't remember who said it. Forgive me, Mr. Genius Guy. And I think he might have actually not even been an engineer. He might have been like a sociologist or something. I don't remember. I could Google it. Whoever said all models are perfect. So all models are wrong, but some are useful. Works for me, and has worked for me professionally. In as much as spacecraft component structural design. Thank you very much. So the mesh will take care of itself, and so I'm just going to right click and say run and see what happens. No, I didn't put a load on it yet. No, yeah, exactly, no loads. Yeah, I knew that. All right, external loads, add a force to this fat line, and I am going to go with English, and I mean, I should give it a direction, but that's as close enough as giving it a direction. So I'm going to call it good. Now, this barbell is 45 pounds. There's going to be 2 hooks. So let's call it 23. Perfect enough. All models are wrong. Some models are useful. I don't need a perfect model. I just need a useful model. And okay. And then I will run the mesh. Run the simulation, which includes creating a mesh. And why is this so small? Can I stretch this? I don't know why this scale is so small. It's never small like that. Why is this? I'm at a loss for why this scale is smaller than it always is. Why? I used a different template. I don't know why that makes a difference. Anyway, I want this to be PSI because that's my language, and it's the deformation is 200. Automatically set itself to 212 times, and it's still barely deforming. So, as I say, this thing is overkill. Chart options. Why is it such a tiny chart? Position format. Why are these percentages so low? Oh, wait a minute. Oh, interesting. And that's just positional. That's not size. That's goofy. Well, I don't know why it's smaller than I'm used to seeing it. That's very weird. But I'm going to have to call it good enough. I'm going to set these values instead of automatic. I'm going to say above the maximum value. I like to not be red. I like it to be like a purple or a gray. But I like to put the maximum value. Well, I say that. It's funny, the independent guy, he was doing gray over the max, and I was like, well, I want to see how much over the max. But then when I do my own, I go back to the way he did it. So I like to see them both, actually. So let's check that for now. And so we are at, why is this so small? I don't know. I thought I could maybe, what is this stuff? Annotation, color. I never even noticed those before. Options. But I really just want to resize this, but whatever. So, PSI. So my yield is 2 to the 2e plus 3. I don't use scientific notation enough. I always confuse myself on it. But anyway, so it's 2 plus 2E plus 3, and I'm obviously at 1E plus 2. So I am like double of an order of magnitude stronger than it needs to be. This is the highest stress point, which is way overkill. But that's assuming it's solid, and it's not going to be solid. That was pretty. That was an oversight of mine. So let's go back into the model, and let's do a shell command to make it much more representative of what we're really dealing with. And that'll also give me an idea of how thick I need my shells to be. So, shell command, where are you? Features, shell. And so typically let's say I do, typically I do 2 shell walls, but this is a more structural thing, so maybe I'll do more. And I'm also doing my layers, my top and bottom layers will be more. And so let's say 4 shell layers, and if my lines are 0.4 millimeter, which isn't necessary, it's a 4.4 millimeter nozzle. That doesn't mean my lines are necessarily 0.4, but let's just say they are for the sake of this. And so 0.4 millimeters times 4 is 1.6 millimeters. 1.6 millimeters. Correct me if I'm messing that. If I'm messing that up. Now I guess my top and bottom layers are going to be artificially. I probably don't want that thick of top and bottom layers, but maybe actually, maybe I do. I guess I do. I do, because that's the top and bottom layers are really the ones that are taking all the load. So I do want a lot of top and bottom layers. So I'll have to tune my top and bottom layers to match whatever thickness I come up with. And so let's do that. Thickness value greater, yeah, okay, whatever. I didn't like that. What can I do to make it like that? I guess I need to make this radius bigger. Where is that radius? Why are these things not highlighting when I'm selecting them? There it goes. Okay, that was weird. Oops, that was the one. And okay, so yeah, so I don't want to go too big on that radius, but this one I can go larger just fine. And you know what? Let's roll to the end. Save my work because I'm about to break it. And so in case the software crashes. And so that was this one. No, it was this one. This fillet. And I'm going to instant 3D it. Wrong direction. There we go. And that fixed my shell issue. Great. I'm surprised this one's not a problem, but I guess it's not. And so I'm going to save my work again, and I'm going to go back into here, and I'm going to rerun the simulation with this piece being hollow. And I'm going to have like 10% infill or whatever, just to keep things, whoa, a lot more in the red, but the funny thing is it's just much more distributed, but it's the same number basically. It's still that double order of magnitude basically. So 2 to the third, however you say that. Whereas I'm like 1.4 E plus 2. So I'm still over an order of magnitude stronger than it needs to be. Now, I'd potentially be concerned about this area, but it's why I put this big arc here to help it distribute that. And I could, in theory, if I bumped this out more, I could decrease the likelihood of that more. But then it kind of protrudes out above the bar. And also, what's the deflection on this? I suspect is still greatly exaggerated. Like, it's going to be automatic, And let's see what the number is. Oh, it's only 17 now. So what's my my actual displacement? The worst displacement, and now this is in metric, but fair enough, is 6 to the minus 1, so 6.9, so 0.7 millimeters. So that's like 30 thousandths of an inch deflection predicted at, oh, and that's interesting, that's out here. I was sort of expecting it to be like around here. Just a little more than I was hoping for, but I think it's probably fine. I think it's probably fine. I have to remember to do the proper amount of shells to come up with that 1.6 millimeters. And there's interestingly, okay, so I knew it was going to deflect from this direction. Can I hit N for normal here? Yes. So I knew that this was going to twist a little bit. I totally expected that, and I kind of thought that that's where the, or sort of here would be maybe not the maximum deflection, but I was thinking that here is be where most of the stress is. Is that the case? I mean, I say that. That's not even really what I meant. But I am saying that this thing is not going to break as it is. And I can really... So the nice thing about this optimization process... Now let me think about, though, how I've constrained it, though, before I... as Harvey Keitel says in Pulp Fiction, and I won't quote him. But let's not count our chickens before they hatch, gentlemen. How's that? So my constraints here, I did, let's say fixtures. So that's my fixed. And that's actually a good sign that there's not stress risers around my fixed little wimpy thing here. And the stresses are very low around it. That tells me I effectively did a fixed constraint that does not influence the actual important bits of analysis where the stresses are happening. So that worked out well. But did my... What? I did 2 fixed. That wasn't supposed to be fixed. Where's... Ah! Haha! Ugh, garbage in, garbage out. This was not supposed to be a fixed constraint. This was supposed to be a sliding constraint. That's... Oh, wait, which one is it? Fixed is here. Slider is up there. Fixed... Yeah, this is not supposed to be fixed. Aha! How many of you caught that ahead of time? So let's add a roller slider to this face. That's going to change things. Alright. Good stuff. It's good when you catch your mistakes. That's how you get people killed in design engineering. Oh, I misplaced this one. Roller, this extra fixed constraint. Yeah, okay. You just killed people. Scary thing about engineering. I try not to do any projects that can kill people. Alright, let's try running it again with the more... so now I have stress risers around this. But I'm going to say that also corroborates that it's probably okay. And I'm not going to try to justify that. Just going to tell myself that. And say, okay, it's my barbell, it's going to land on my head. I'm putting myself at risk. Good enough. I don't need to go to the independent aerospace structural research company to verify that my barbell is not going to land on my head. So, now, no, we're still, I'm still the same. Okay, somehow my max stress came down. Isn't that special? I made it sliding, and I made it more realistic, and my max stress actually came down. I'm tempted to look back and see where these stresses decreased. But it's irrelevant. How about my deflections? My displacement? Is my displacement... my displacement has increased up to 1.5 millimeters. And it's much more twisting. Remember I was saying how I expected it to be twisting. And what's my exaggeration on this definition of this deflection? It's showing it at 8.7 times deflection show. So like I could change this to, let's see if I could call it 50. Yeah, look how much it bends now, huh? That's 50 times exaggerated. Now keep in mind, this is... And I mean, this is kind of nonsense because it's... I have the bar... Again, all models are wrong, some models are useful. The bar is going across, helping this to stay horizontal. So if I put a 23-pound barbell just on this side, then it would deflect much more like this. But whereas I'm going to have them balanced across two things a bunch of feet away from each other, with an iron bar across between them, steel bar, probably not iron, though there's iron in it. Just like tin foil is not made out of tin, but whatever. Actually, you know what? This probably is there actually tin and aluminum alloy? I'm going to ask that question right now. How much tin is in aluminum foil? Now, interestingly, you can't use pure tin in spacecraft stuff because it makes whiskers, and then they break off, and then they short out electronic things. Aluminum foil is 98.5% aluminum. Silicone. Is there tin in aluminum foil? Tin foil was made with thin leaf tin and sometimes combined with lead. Aluminum foil is made from blah blah blah. Cheaper to make than tin foil. They're not telling me. Alright, so you know what? I just need to go back to MatWeb here and say aluminum foil, and I should be able to get the chemical composition. Aluminum foil coating, aluminum foil tape, aluminum foil tape. It doesn't say adhesive backed, so I'm going to say that that's going to give me potentially, and it doesn't give me the chemical composition. I mean, I'm leaning towards there's actually no tin in aluminum foil, so there. That's my assumption, and I'm sticking to it. Okay, meanwhile, back at the ranch, my deflection has gone up. My stresses have gone down. Let's go back to the stresses again. And let's again look at my... Let's continue to revisit my fixtures. So I'm going to change this because it's the way it's really going to work is it's going to be all on this forward edge, really. Just as it's all on this top edge, on that face, it's going to be all on this forward edge. So I'm going to go back into my model, and I'm going to select this face and create a rectangle on it. I don't need a whole rectangle. I'll just create a line. Call it, it's going to be, thinks it's vertical. I can tell by this UCS icon here, and I'm going to say, again, this is like 0.05. Enter, and then split face, split line on that face. Why does it do that? I don't understand. Please select one or more faces to create edges. What? To create edges? I don't know what's going on there. It's consistent though. But anyway, I got it to work. Okay. Now, if I go back into here, Now I broke that fixture, and now it's cool. And I'm going to edit it. It's actually good that it broke, so I don't forget to redefine it. So I'm going to change that to just here. Now, what about this one? What's really happening here? Because as it wants to twist inward a little bit, it's really going to, a lot of it's really going to be concentrated there. I'm actually going to change that one also. Where's the split line? Is that this one? Yeah. I'm going to add another line. Let's just offset this by 0.1, say this direction. No, I said 0.1. And that's just arbitrary anyway. So now I have that, and so I should have broken this one also. Ah, no, it didn't figure this one was broken, so I just need to, oops, I need to edit this guy. Instead of this one, I want it to be this one. Alright, so I think this is typically how all models are wrong, but some models are useful. You iterate, you make a almost useless model that will fool you into killing people, and then you gradually refine it until you scrutinize it enough that you're confident that it's good, perfect enough, as I like to say, and probably annoys people, and that's fine. I guess that's kind of, if I'm honest, that's kind of how I roll. All right. So, how are we doing now? We're still at our max stress is still. Oh, you know what? I bet that max stress is down here by this, and that's why it keeps giving me that max stress. But these are also in the red, so they're all. That's so weird that they're. I'm going to adjust that scale because I'm not sure why these are all so close, so uniform in stress. That seems weird to me. So I am going to edit this definition and manually define what's shown here. And so automatically define minimum value. So 142. Okay, yeah, because my yield, I made my yield only 2,000, and so yeah, that does add up. So, oh, that's why, because I had automatically defined maximum value, unchecked, and so therefore that. So I'm going to call this minimum one. I'm going to call it 1,000, figuring anything that's not, okay, all right, so it was breaking. All right, I see, again, this is why you have to be thorough and check and recheck, because you accidentally uncheck a box, resulting in product end users dying because the barbell fell on their head. Okay, it's good to, and you know what, I'm going to leave all these mistakes in there just so you can see how things really work in the design world. Must be less than the maximum value. Okay. I'm just going to keep it automatic for now. I think because of the previous mistake, it's not letting me change that yet. So I'm going to rerun it. Now it'll make a whole lot more sense, I think. Now I'm way above my max stress here. So my yield strength is this red arrow here, 2,000, 2 KSI. And again, that's half of the yield strength of industrial produced polycarbonate, whereas I'm 3D printing it, so mine's going to be less strong. And I'm also putting a linear analysis on a non-linear behaving material, and so I just need it to be way overkill, so that way I don't so the so the curve in the nonlinear curve is basically close enough to linear because it's such a short section of the curve. Does that make sense the way I said it? It made sense in my head. It doesn't have to make sense to everybody. It makes sense to me. So, where are my max stresses? Surprisingly not here. I don't have a radius. Yeah, I do have a radius there. Yeah, there's a radius there. I want this radius to be bigger though. I go back. Ah. Oh. Oh. Yeah. Yeah. Let's do that. And then this one. Yeah. And then I'm going to make this a big fat radius. Now that's useful. That's what I'm talking about. Nice chunky radius there. Because that, well, I say that, it's really, now it's, as I think about it, because the way the barbell is going to remain horizontal. And therefore, it's not going to put a big stress on there. And that's why there wasn't a big stress on there. So I'm going to change this back to, let's say, 0.1. And if I get a stress riser there, then I'll increase it again. But I lost the rest of my radii here. How'd that happen? This guy and this guy, and give them a 0.06. I wonder if that would mess up my shell. Messed up other things. Oh, it messed that. Yeah. Oh, so I put that in later. There we go. But what did I break? I broke this split line. Oh, I just lost my reference, that's all. Let's display delete relations. I could try to replace that. I want to try to replace that. Sometimes I can get that to work and sometimes I can't. It's very iffy. Okay, I got it to work that time. So whatever I did there, that's how you do that. I've had so many times where I try to do that and I can't. You have to do things in just the right order, and sometimes I fail. Sometimes I don't. But I did lose that radius on that surface, so I think I can hopefully. Oh no! How far back is that radius? I'm going to apply that here. But I want the. I want it to be before the shell. All right, perfect enough. Again. All right, let's run this again. See what happens. Okay, so I do have a little bit of a stress riser here. I am way over the max stress. Where? Here? No. Where's my max stress? There. Not a huge surprise. And that is not big overkill in design. And so that's why I'm doing this. So that is fairly likely to fail there. Now, on the other hand, again, the barbell is pushing downward evenly across this. A lot of times you get these very concentrated max stresses, and it's It's more of an artifact of how you make the sliding fixture, and it's not real. But what tells me that it is kind of real is that this yellow is also over, and a lot of this green is also over my safety factored 2-to-1 safety factored yield strength. And so therefore, and also, interesting here, this is also approaching my safety factor limit. These are also. So I can make it thicker walls, or I could increase this thickness here, but that's not really my problem here. Although that's a little bit. And this doesn't need to be nearly this tall, and this doesn't need to be nearly this tall. Assuming, so let's go back and think about my fixtures again. So I'm saying this is, that's allowed to slide up. So that's pretty representative of it. I think that's a safe assumption. This guy is allowing it to slide forward, and it kind of catches on that guy. And so I think that is a fair representative. And then this guy is sort of just sliding on this portion. And because of the way this twists, I think that's also a fair representation. Even though the bar is helping it to stay straight, it's helping it. Really, the bar is constraining it in two degrees of freedom. It's only really, the bar only really leaves it the 1 degree of freedom for this to curl down, to uncurl downward, the tip. But I am going to leave, I'm going to call it somewhat overkill. Like I say, I want to design this for overkill. But I can eliminate a lot of this plastic. So let's save this. First, I'm going to eliminate the dark blue areas. And did I lose my display states again? I did. I don't know why it's giving me persistent. This transparent keeps coming back. When did I make the whole part of that? I don't remember doing that. Okay. So this here was way too blue. This here was way too blue. So I can adjust this significantly. And so what I'm going to do here, I'm going to, that's not what I meant to do. R for rebuild is not what I meant to do. I meant to do T for trim. I'm just going to trim this back to like here. And I don't want this to any longer be tangent to that. I'm going to save my work. S for save. And this angle. So this should get significantly stronger. And it turns out I need something more like this. And make this tangent to this. And that's already, whoa. Let's just give this a angular dimension of, say, I don't know, 10 degrees. And I'm a little confused right now. Let's give this a distance of 0.1. And let's put it right coincident with that line. Now can I? Yeah, now that makes more sense. Except, let's do this. Let's call this 0.1, no, 0.06, which is even more than it needs to be. And what is driving this? Is it this angular dimension? Let's make this driven. How many times did I say that backwards? Okay, that's still not constraining it. I think there's like, so sometimes a curve will keep a, you delete a constraint and it still acts as if you didn't delete it. So I want to delete that. I'm going to delete that. Yes. I'm going to bring this up here. And I think I can get away with just making this a line. It probably doesn't even have to go that far. It'll probably just go down halfway. It'll probably even just go down to here. But I don't want it to accidentally jump off. So I'm just going to do overkill as usual. No. I meant to drag that. And then I'll make these tangent. And, whoa, those aren't tangent. Tangent. I don't think that needs to be much. I'm just going to put a little bit of an angle on this. I'm going to put an angular dimension on this. I'm going to try. Let's say 3 degrees. That's even overkill. Reduce that. All right, that looks good. And yeah, let's do this. Let's trim that back. Let's trim this back. Let's do this. Trim this. Tangent. And give this a number. And let's just call that, what's 0.5 going to look like? And I mean, worst case scenario, someday in the middle of the night the barbell falls. Because I'll see this. If it's going to fall, I'll see this thing spreading. And so because I made that 0.1, I'm also going to make this 0.1. That's where I was ultimately going with this. Just to make these match. Don't forget I also have this radius in here. And see, I don't want the center to be inside this box. I want the center to be outside this box. That's going to make it not the weak point. And I'm even going to exaggerate that. So let's say, just to put a number on it, let's call this like that. All right. Now what's going on down here? Things are not fully defined, and I don't care. Let's see what happens. I broke stuff. Oh, I broke a lot. Now, I didn't save myself a backup, so I don't remember exactly what went where. Okay, that was just recreating the. What I deleted the vertex or something? Yeah, up to vertex. Can't find the vertex, so I'm just gonna go. I'll just redefine the vertex then. So that fixes that. And this again probably lost its vertex. Oh, open contour. What? Oh, this is that curve. So I'm going to make a tangent curve here. Make that tangent. I'm going to call this very small radius 0.02. And then this guy can do this. And so I'm going to dimension that to that and call it, I don't know, 0.31, 5/16. Rebuild. Okay. I mostly like how that looks, although I have broken radii. So I guess that was this one. And I guess that was this one. I don't like this edge. Ah, that goes away later. What did I break? What did I break now? How did I break that again? Ah, I think I know, because I fixed the radius and it gave me an extra. Ah, how about that? Okay. Let's just get rid of all that. Back to where I was, because I fixed my radius, and so it might not have even been broken had I fixed the radius first, but that's okay. I improved it. And that looks so flimsy now that I look at it like this. How could that possibly be effective? Because that's just not where the stresses are. It's an interesting thing about stress analysis. Structural analysis. Stress analysis. Sure, stress analysis. I'm going to call it that. Fill it. Ah. Ah. Okay, whatever. I'll take that. Did it mess up my shell though? That's still shelled? Holy cow. Okay. Okay. Now if that twists out, that ain't going anywhere. Alright, let's see. Let's run this analysis again. This video ended up being way longer than, as usual. My video ended up way longer than I intended it to be. Ah, broke my fixtures. Oh, aha. I broke the fixture. The true fixture. Add a definition. And this should again be fine. I expect to have some artificial artifacts. Is there such a thing as artificial artifact, or is that a redundant redundancy? Let me know in the comments. Oh, by the way, please give a thumbs up if you're watching this. Then give a thumbs up, please. And maybe even subscribe. Maybe even share it with your social media. Alright, let's run it. I'm getting a little tired and I'm hungry. There's no load. What? No load. And it's like multiple bodies, right? What is it? There is no solid body to process. Alright then. If you say so. And what if I delete this fillet? I mean, my face is still, yeah, I got that guy split. I got this guy's split. Yeah, these look right. I got these guys split. For some reason, it doesn't see a body anymore. Solidworks is quirky. How about if I try just running the mesh? No valid bodies. Oh, you know what? I think I know. It says solid body, but I think the shell is unhappy somewhere. So if I rebuild the shell, how did this go to? Oh, I did it in metric. That's why it's a goofy number. Thickness value greater, blah blah blah. Yes, thank you. How about? Oops, that's not what I meant to do. Just making sure it's still. Yeah, it still doesn't like it. Still unhappy. I think I need to beef up the totally wimpy sections here. That is the sketch. I am going to maybe that'll take care of it. Or not. But it could have still. Let's try it. Let's see. No, invalid body still. Okay. What? That's not what I meant to do. Alright. I'm going to do a little thing called divide and conquer here. Advanced technique. I'm going to chop this thing right off and see if that fixes it. And then I'm going to go shell. And I say okay. Okay, so that's not necessarily where the problem was. Now if I make this visible and turn my sketches on so it's really visible, and then do this, and then do this. Still. So evidently in two places I have too much. It's too minimum thickness. Let's press that. I just think I just saw. Maybe it's my imagination. Let's go back to my transparent display state. Oh, okay. That didn't really do anything for me. Let's instead do a section. Turn off the sketches. I'll do a section. So this may seem tedious and boring and long and all that, but it's actually sharing legit experience with you so you can see how problem solving can be achieved. Interesting that those aren't filleted. Probably not the problem, but I want them to be filleted. I think 0.03 is just too small. Could be part of my problem. Although adding these radii may actually be the problem. It could be. I don't think so. Why doesn't it want me to do that? Oh, because of the... Okay, it does not want to fill it that. How about if I go to before this? Still maybe not. Now it's happy. Yeah, I'm going to leave that at 0.06. And then, does that break these? No. Good. And still doesn't like it, but what? Okay. Okay, which one was it? I don't know. Why can't I see that thing? That's that guy. I'd really like this better if I could see. Okay. I have mixed feelings about this new snipper tool. Open, damn it. Oh. Why is that fighting me? Stop fighting me. That took like 47 clicks. What was that about? Okay then. Alright. That's approximately where it's oriented. So that way when I go back into here, I can make sense of it. Fixtures. That's that guy. That's that guy. That's confusing. Did I break my split line? No. Definition. And I'm doing this blind. Oh, I can't even. That's annoying. Alright then. Oh, that's ugly. Alright, let's regroup. That guy's right. I think. That guy should be fine. That guy should likely be fine. That should be fine. This 0.13. I mean, that could fix it. Ah, what? Oh, because of that huge radius there. Split the difference. Ah, so that fixed some things. If I just go back in here, can I see it? No. Well, isn't this a rabbit hole? Can I select on here yet? Anywhere? Anywhere? Bueller? No. Something's not happy. I am going to just make this, for now, arbitrarily bigger. See if that helps. And I broke everything. Not sure why that broke that. Or this. And alright, I can guess why that broke. Tangent. I feel like I'm gonna sneeze. You know what? I don't know if this is just like a psychological placebo effect thing, but I remember way back when somebody telling me if you're gonna sneeze and you can't sneeze, and you're like, I want to sneeze, but it doesn't come out. They say, look up at the light. And I look up at the light, and then I sneeze. I don't know if it's the looking up or if it's the looking at a light. I think it's probably more like looking up, but maybe it's just more placebo. But maybe it's actually looking up. I don't know. Now, this guy isn't helping me that this is 0.03. Can I do like 0.1? Nice. Although, I kind of don't want 0.1 there. Let's go 0.06, if it'll let me. Well, let's first see, does that fix my problem? Still doesn't fix the problem. So let's call this, no. Where are you? Where'd the dimension go? There it is. 0.07. And rebuild, and it's still invisible. Well, I mean, I could, how much time do I want to waste on trying to save a little bit of material? Let's just do this. See if it fixes it. Okay, did that fix it then? I still can't see it. If all the time that was the problem, well, for some reason it hid that, that would be goofy. Regardless, it's only a little bit of extra material, so I don't care. And I am going to reduce it. Ah, that's not the right button. Model. Oh, no, that was right. Fix that. Fixture. Holy cow, that was a rabbit hole. I got past it though. Now back to the actual work. And we're still significantly over. No, I mean, I did also thin the walls out a little bit, so. But let's see, where are my, so basically greening up are my problem areas. So this makes more sense though. So this and this is where I would expect to see the most stress. And the here and here and here are also where I would expect to see the most stress, and here. And back here, we're really in good shape back here. This is just starting to get a little stressed, but again, that's because that is my true fixed fixture. The other ones are roller sliders. All right, so we are getting there. But I do need to make it stronger. Yeah, so theoretically I could make the shell thicker, but if I just sort of make this portion thicker, that will save me down there. Now here is a different story. Here is more about the shell being thicker. But if I put a rib in here, it's kind of, I don't like that because it's in plane with the layers, and that is not ideal. I mean, so actually, so here and here and here, that's my real concern because those are in plane with the layers. Like this, like I mean, so each layer is like the capital J, and so this is just going to put in tension one of the layer lines, and that is stronger in theory. Although with polycarbonate, it has such good interlayer adhesion that it may not be a problem. But I am going to treat it as if it is. Therefore, maybe I do just want it thicker. More shell walls. What happens with my shell minimum curvature thing I'm going to do if I do that? Let's see what happens. If I make my shell rather than 0.06, if I make it 0.12, and the shell does not like that. Not a major surprise. And it won't even do it anyway. Alright, you know what I'm going to do is get rid of all these radii. Or maybe not all of them, but at least this one. And this one. And rerun it. Alright. Let's do that just for now. Let me do what I was originally going to do, which is add a... Haha, this is going to be even goofier and better, and safer, I should say. And you say, what? This is how I roll. Oh. Ah. What? Oh, because I did that. I did that. Wait till you see this. My external load went away. Oh. Yeah. Oh, it even did this. Oh, I see. So this is why you don't be lazy and put sketches on surfaces, because it bites you later. Add a sketch plane. And oh, looks nice. Looks like I can unsuppress it now. Did that bring my radius back as I didn't want it to? It did, unfortunately. Wait, what? Yeah. So I need to get rid of the offending constraint. Could be it's probably a midpoint. Could be a distance. It's the rest of them. It's not going to be the rest of them. So I should be able to now suppress that while still having this split. Nice, nice. All right. External load, redefine. All right, now let's see what happens. Am I shelled? Yes. But did I double my shell? No. 0.12. Does that work? Please? Please? Nice. Alright, 0.12 shell. Oh, interesting. I didn't get rid of that radius and it still worked. Good stuff. Okay. Let's run this. I'm getting mentally fatigued and hungrily hungry. Some black coffee will take care of everything. Alright. Where are my stress risers now? So it's funny to see how much this stuff deflected, and I'm fine with that. And that's I do that intentionally. So that way I know that this fixed fixture is not interfering with the motion of the part. A little trick I've been using for a long time. And so I just have that one tiny stress riser right there. Now I am going to adjust this color mapping here, color scale, to be more precise. Automatically maximum. I think I'm okay with that. And then automatically minimum, and I can change it, but let's call this the 2000, which is my safety cutoff. So now anything dark blue, that kind. Oh, I know what I want to do. I want to change the color. Change the color. Under 2000 will be a different color. So under 2000 we'll make gray. Oops, check that. Make this gray. Okay. What? So this thing is so overkill. Except right here. I kind of knew that when I doubled everything, it would more than double the stiffness. But I still have to mitigate that stress right there. So I mean the rest of it. Actually, let's change this to 1000. Wow. Okay. I stricken myself there. So let's make this anything under 1000 is grayed out. And that'll be my real happy place. Alright, so I mean, so much of this is just way overkill. Except for right there. And so, and right there. I can do some trickery to make those stiffer. Although, those are already solid. I mean, so in theory, if I overload it, and it may not even really be overloaded, because really, my stresses here are still under the yield stress of actual. It's only like 25% of the lowest published yield strength for any polycarbonate. So it's like 4 to 10,000 or whatever it was. But that's, solid, zero porosity structure, for lack of a better term. Whereas I'm 3D printing, and so theoretically I don't have perfect interlayer adhesion, and so I'm taking the lowest number of 4,000 and then cutting it in half to 2,000. So I'm still at 3,000. So I still have a 75% safety factor at this extreme point. And I'm saying, and plus if I have a radius back in there, can I get that radius back in there and rerun it? And still have the shell be happy? Let's try it. I gotta do it before the shell. Fill it. Let's see if that still plays nicely. Oh, everything's looking okay. Interestingly, what was I at? No, I was at like 3,000 before. Now I'm down to like 2,500. So really, that is getting better. Oh, and that's actually only here. So here is even lower. So I could feel comfortable calling this good enough. What I don't like is that I have all this extra material in here that is just unfreaking necessary. Oh, I know what I can do now, which was my initial plan, which was to taper it in that direction. And so, and let me change the scale to show to demonstrate what I mean. And so I kind of see, I've been doing this stuff so long, I see these colors, the way they're going to distribute very roughly in my head. And then obviously there are some surprises because I'm not a total computer, but I can kind of see in my head like where I can taper things down, because the stress is just going to reduce as the leverage is. That's not a good way to say it, but anyway, I can see ahead of time where I know I can taper things down. So right from the start, before I even laid any of this out, I intended to potentially do some tapering, and I'll show you what I'll try to demonstrate here. Automatically define maximum. No. Anything under 1,000. And anything, then the minimum value, 0. I might want it higher than that, but let's call it 111 for now, just to do something. And specific color for this, anything over it is black. Okay, so you see the black there. You see not black there. As I mentioned, this is not quite up to not the highest stress point. And you can see the interesting that this, interesting. So I can taper up top more than I can at the bottom, theoretically. Although this is such overkill down here that I can thin this out significantly down here. So let's do that and rerun it. I could have saved myself so much time and effort and just printed it way overkill, but I'm just sort of doing this exercise to optimize my shape. Let's do, I'm going to save, and then I'm going to save a copy, and save a copy as my little workflow there to save backup copies. In case I break it, I can always revert to where I just was. Because where I am right now, this works. Like I could make this, I could cut this thing off and print this, and it's going to work great. But I'm going to increasingly decrease my. I'm going to decreasingly affect the plastic volume here, and not even by much. It's kind of a waste of time, but just to show how it's done. And I really should do that because I am very hungry right now. I might even keep working, stop talking, and grab my sandwich that is already made. But I won't do that to you. So if I take this... interesting. This could be interesting. So because the way I structured this, this is driven, and this is calculated based on this, and this is calculated based on this. Let's see what happens if I decrease this, if my taper effectively decreases as I intended, and no, it didn't. It just broke. Okay. Why, I Didn't like that at all. I can increase it. Yeah, okay, it is the up there. It's the up there part. Ah, interesting. Let's get rid of this angle. And call that that. That's perfect enough. And so now, can I adjust this now? Nice. Nice. Except, or, you know what's not nice, is I can't get the bar in here now. See what I did there? So like if I make another circle, same size as this, I can't get it out. I can't get it out. Alright, so let's make this construction and just leave it here as an indicator. And did I set this at an angle? Ah, interesting. Well, isn't that special? Oh, because I eliminated that line at some point. But that's fine. It's not going to jump up more than its radius. I could go even lower than that. Even that is going to be plenty in there. Might not be plenty strong. But alright, so now I can get this in and out. And let's see how this looks in the old FEA ski. S for save, run it. There is no load. Fixture or contact in the following bodies. What are you talking about, Willis? It's funny how I said that entirely incorrectly. What is it stuck on? I can't escape. It doesn't want me to hit escape for whatever reason. Okay, there we go. Not sure what that was about. Kind of fun. Oh, did it include in the analysis? I wonder why it does that. Run. What are you talking about? Oh, I must have broke my shell again. Must have broke my shell again. Yeah. All right, so I got too carried away with adjusting that. So let's. So what was this 0.63 before? Let's call it that. There we go. Let's see how this looks. So we are, I mean, we're still only at 2600 KSI, you know, 2.6 KSI at the, and that's not even real. There'll be a radius on there, like this radius here, so I'll be back down around 2200, which again has so much safety factor already built in. Look at, it's funny, this deformation lines there. In any case, here I am in the green, so I'm well under my desired safety factor there. How much does it deflect? 1 millimeter. Okay. A little more than I'd like, but realistically, it's probably fine. I could potentially beef that up. But anyway, so I lost the focus of where I was going with this. Is I was thinking that I could taper some of this down, like from left to right in this view. I could taper it down. But here and here are really my key stress points. And they're uniform. So I don't necessarily want that part to be tapered. And up here to here seems to be similar, in fact. I think I could taper that down though, but like who cares? But let's Let's try a little something. Let's go back to before the shell. Let's do this. Okay. And actually, that's overkill. Let's just to do something. Okay. And then on my top plane, let's put a line going this way, just arbitrarily. And then I am going to extrude cut that, but I'm going to give it a trajectory. Is that what it calls it? Vector? Direction? Yeah, I guess it's not a vector unless I give it a length or a factor, value. So as you can see here, so I sort of taper that down. And let's, I don't like that it does that. Let's, why, oh, huh, interesting that it didn't consume that sketch or hide it. Let's do this though. Ah. Did I not? Oh, yeah, of course it did. See what I'm doing here? Oops. So, that's interesting. That's interesting. Yeah, I'll show you. I'll show you. Now let's see what happens. Now it's just getting ugly. Now I don't even want to do that just because how ugly it is. But that's okay. I can pretty it up after. We could put lipstick on this pig. So, as you can see, my stress risers here are still uniform. My stress risers here are still uniform. My stresses across here still plenty strong. That didn't make any sense what I just said, but it kind of did. If you can translate from my internal mental language to reality, we're really in the same place that we were. See what I'm saying there? So let's take that a little further. Let's go back into the model. And this guy, I kind of like where that's at. It's this guy that I want to change. Oops. And let's go normal. And I'm going to do a spline. And I hate doing splines because I find they're buggy and they crash my software if I just stretch them around. So I'm going to try to just not stretch it around. Please help me to remember to not stretch it around. to not stretch it around. Then I should be fine. Although I did save my work, so even if it blows up, not the end of the world. And I'm also going to do an ellipse, or a few ellipses. Why do you do that to me? I mean, I'm really looking for trouble now. Alrighty. It didn't want to cooperate with me too well there, so I fixed that in place. And let's this guy. Huh, okay. Uh-oh. Oh. Alright, I don't want it to go that far. Oh. This guy. I don't want this guy. Oh, actually, though. I can get away with something like that. If I go further up. Nice. Nice. Now let's see what happens. I mean, that shelled. I didn't double check that that shelled properly, but it looks like it shelled properly. Ooh, excessive displacements. I made it pretty weak. Wait a minute. No. Yeah, that got ugly there. So did it shell though? Yeah. Oh, okay. So it didn't shell. Excuse me. Up there. Interesting. So let's adjust these shapes a little bit. Let's just scale this guy down. Down 33%. And let's run it again. Oh, interesting that I did away with most of this tab, but it's still there, so it should still be effective. And, why is the split line not happy? Oh, okay. Oh. Let's get this down a little bit so that split line isn't interfered with. I mean, I could have just fixed that a little bit. I got room for another ellipse up there. Yeah, I don't want to interfere with that. So, but is that shelled up there now? Yep, good. Because the only reason I have it shelled is so it's an accurate structural analysis. If that were solid, then those stress risers would be artificially stronger than in reality. Alright, let's see. And so again, my max stress is 2.5. Oh, has it moved out of town? Where is it now? Well, anyway, down there we have plenty of strength here. Plenty of strength here. Interesting. We're a little bit on the stress risery side on the ends of this ellipse here. That's interesting. I could be looking for trouble with this ellipse, just because of, you know, this is going to be in tension, and that's no, I'm printing it. Okay, right here won't be, but right here, well, the layers will be in shear. The layers will be in shear. The layers won't be in tension in the direction of the layers, but they'll be in shear. Probably fine. Like this side I'm not worried about at all. This side, I'm going to reduce this ellipse a little bit. Well, isn't that special? So as I said, I'm less concerned about it on the left side, so I am going to bias it to help the right side. I wonder how I could probably go lower. I don't want to go below. I don't want to go below this line. Oh. Nah. No. What did I do? I did select other. Okay. I don't want it to be below that line. That looks pretty good, and I'll have to extrude the other direction. Oh, I already am? Oh, I see, because of the way this plane is. Am I into this surface? No, somehow I'm not. Alright. It's looking pretty good. Let's see what the fairly organic shape here. Sort of a cyborgy non-organic organic shape. All right, run. Man, I'm getting flaky here. I'm hungry. All right, so my peak stresses are still similar. These stresses over here is a little higher on this side, but again, I'm more okay with that because I don't have anything in shear. Like on this side, I've mostly eliminated this portion in shear. Here is also going to be in shear a bit, but I think my stresses, we're into the blue here, approaching gray. So those stresses are very low anyway. Most of the stress is here, 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 and here, and even those numbers are down in the, geez, not even into the light blue. So, you know, 600 psi, psh, big whoop. And up here, we are up over 2,000. Do I want to improve that somehow? I mean, here I'm still under 2,000. What about my deflection? Displacements. 1.5 millimeters on this one. So now it is starting to twist a little bit. But again, the barbell will help fight against that, which in turn will help reduce the stresses near this. So this side is even less stressed. So the question becomes, and what's this going on here? This looks plenty strong. And the displacements up here in the blue-gray region. So I mean, we're talking, you know, like steel gray type of, yeah, we're talking 1/4 of a millimeter, 0.010 of an inch deflection. That's not going to fall off. Question is, do I trust these structurally here and here? That's really the only place I'm concerned with. And I've also potentially creep over time, like slowly creeping. But I don't think, this is also going to be an interesting test for my hypothesis regarding how to effectively run a reliable enough linear structural analysis on a non-linear material. And that is slightly concerning. I'm going to put a radius on this so it's less real. And I wonder what the stresses are inside there. Can I check that? I can. Oh, here's a neat thing. ISO clipping. I forgot about ISO clipping. ISO clipping allows you to run a slider to show you only within a range of stress. So as you can see on the inside here, it's plenty strong on the inside here. It really only goes up. So let's say if I put the ISO clipping at 1,000, so I'm sort of doubling my already significant safety factor. I mean, from there to basically to yellow. From green to yellow is all approaching being stressed. And does it go all the way into the interior? I guess it does. But I also don't have, wait a minute, what am I looking at? I'm confused. Okay, I see. So this side doesn't make it all the way through to the interior. This side does. But, again, I don't yet have radii on there. So when I add back in radii, let's cancel that. I'm hungry. I need to eat. Let's call this almost done. Okay. Need radii before the shell. Alright, focus. Radii before the shell. Radii before the shell. Especially... Okay, that one's already there. Well, that's interesting then. What? Let's look inside here. Oh, it's before the shell. Stupid. Okay, radii before the shell. That is more radii than I was hoping for. More aggressive. 0.05. 0.0. Actually, though, the more I put, the stronger that gets there. What happens if I select this? No, doesn't like that. How about, let's get rid of my sketch visibility. What if I do this? No. How about if I do this? Yep. Ooh, didn't like that. No. Yep. And I mean, I can make this even bigger. Wonder why I didn't like this one. And now it likes it. Okay, then. That's pretty cool looking. Oh, now it does like that. Sweet. Looking good. And then over here. Oh, and here. No, didn't like that. Does not like that. Well, I don't want this to be sharp. There we go. How about this guy? How about this guy? How about this guy? Nice. Ooh, we got this guy left over. Let's just be lazy and just do another one. I think that's all my sharps. Now, what's the chances this is going to mesh? 0 to none. Right? It didn't even try to survive that. Okay, I got a little bit carried away there. Let's, what did I do? I wanted to add that one. That's all I really wanted to add. So let's do this. Roll back to before here. And run it again. What? What? What did I do? Thickness, blah, 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 yeah. Okay, that took. How do I do this? And this. Ooh, my fixtures. Oh. Oh. Aha. Ah. I know what I need to do. I need to roll down all these, but then I need to suppress these is what I need to do. Huh? You know what? I don't even need to suppress those. Maybe. Ooh, this is looking ugly over here. I can't imagine this is going to work, but let's try it. Oh, this is, that's super ugly. Let's move this to up before this radius. Oh, it doesn't like it anymore. How about if I make it larger or even smaller? Let's get rid of this co-radial. What? Oh. I see. But why didn't it not? Why did it not? Not happy. Not happy. Maybe? Which one is that now? That was... I forget which one that was. Okay, that's that upper one. Oh, did I break my split? How did I do that? Where's my... Oh, duh. There's that. Alright, we could be cooking with gas here. Alright, so our peak stress is still 2584. Keeps pretty stable there. So that's obviously somewhere consistent. I can tag the peak stress region. Let's see. Edit definition. Options. Show max, yeah. Okay. So inside here is the peak stress. And just thinking if I were to care and want to mitigate that further, then is there really much I can do about that? I could do a move face on the inside wall here. I can in the model, but I can't really in the print. Unless I just make the whole print hollow. Which realistically, the way I've structured this is I could save it hollow and print it with no infill. And it should print fine. The trickiest part would be this here. And maybe I'll just increase the radius inside there. How can I do that? I think I may. So let's go back here. Save a copy. Okay. let's section this bad boy. Does that work? No. There we go. Ah. There we go. That's what we want. And I don't like this coloring here. Is that because of my lighting? Or no, it can't be because it's so shadowy. Off in SolidWorks. No, okay, let's turn it off. Edit. Why do I not see edges though? Well, duh. Okay. And why is that not radiused inside? Okay, I was expecting that to be radiused insidewards. Oh, let's but I guess because of the minimum curvature thing I do. Let's see if I can. Nice. 0.05. I mean, even just adding a radius to that might even do it. Alright, well, I don't need it to be perfect. Oh, and I didn't even need it up here at all. It was down low that I potentially need that. But that's sure not going to hurt. Add a little bit of material. Didn't like that. Yeah. Yeah, I'm more worried about that side than this side anyway. Yeah, I was thinking about sharing this model, selling it online, but I wonder if there'd be liability. I would definitely say test first. Don't put more than 0 pounds on it. It's for decoration only. Plenty of disclaimers like that. Anywho. I mean, I still have that same number. Same place, same number. But I bet if I do my ISO clipping, it's much better. So if I go to 1,000. Interesting, over here is so much lower than over here. Alright, so that's the actual inner wall. So the inner wall here is below my initial safety factor, which isn't an extremely aggressive safety factor, really. I could be a little more cautious, but there's just so many things that are keeping it from hurting anything. I'm really not plus polycarbonate is really strong material. Let's ask Google how much polycarbonate creeps. Polycarbonate exhibited. Let's do this. A nonlinear creep response at stress levels above 24 megapascals. I don't know what that means in earthling units. No, actually, that's engineering units, and I shamefully am not good at. I don't know. So like a pascal, I want to say is like 3/4 of a pound, and so no. I'm confused. I'm hungry. My brain's not working anymore. While nonlinear behavior in microcellular polycarbonate was initiated at lower stress levels. So convert 24 MPa to PSI. That's why I always have this crutch of Google forever now. So I need to know megapascals. So what did I say? 24. Okay. So over 3480 is when it starts to creep. And I am so far under 3480. So that sort of corroborates my safety factor. So if I'm already at if I'm already saying 4,000 yield, which is the lowest I saw published for extruded polycarbonate anyway, and so then I went to 2,000. So that's a 100 to 400% or whatever factor of safety already. And then I'm going beyond that, mostly except for my artifact stress riser at my unrealistic, because that's also sitting on a radius there, so that also decreases the real stress riser because the square tubing that it's sitting on has a radius, outside radius. And then I don't even have to worry about creep here evidently, because 3480 stresses above that, it tends to creep. And what did it say? While nonlinear behavior in microcellular polycarbonate was initiated at lower stress levels. Nonlinear behavior. Yeah, okay, I'm fine with that. I'm not sure exactly. That could mean multiple things. But I'm going to say that this is looking pretty freaking cool. I didn't want to keep the ISO clipping, so let's turn that off. Show contour on the uncut portion. I don't know what that means. Oh. Interesting. Okay. Any case, oh, cool. I just disable it that way. That's what I want to do. Okay. So let's just revisit this. So my stress is here. Pretty damn low. You know. 1-ish. One KSI-ish there. And that's only right there. And here, even less. Here, even less. All in these stuff, looking good. Over here, a little stressed, but well under my safety factors. This guy, just stubborn, doesn't want to. But you can see that's just that one node peaking. And again, it's artificial because it's showing on a square edge, which it's not sitting on a square edge. It's sitting on a curved edge and radiused edge. And these red spots were much more pronounced before. Now they're just very faint red, and now it's back into orange and yellow. So that has come down quite a bit. And this all looks pretty damn good. And so I'm going to save this, and I'm going to adjust this contour. This is kind of a little sharper than I'd like to see it. So I'm going to save my work, save a copy of it. What happened? That's weird. Why won't it let me escape? That's weird. So now I'm going to try to... Why is it... my shift key was stuck. There we go. Okay. I'm going to edit the sketch, and I'm probably going to blow up my Solidworks by doing it. Although if I just move it... No, I can't do that. If I just redraw it, that's what I'm going to do. I'm going to redraw it. Let's do this. Keep out zone. Do I have keep out zone here? Okay. Okay, I think that's prettier. Let's add, ooh, I broke stuff. I broke stuff. That was already broken. Well, I mean, I suspect that I just made this edge go away more than I broke it. Oh no, it was a face. It doesn't like to, tiny little radius there biting me. Okay, I can deal with that. Let's just do that. And then whoa. Aha. All right, and can I add this to this? Nice. Looking good. All right, let's do this one now. Where? So it's totally missing. I'm going to reduce this one just a little. Yeah, just a little more. Huh. Never mind. I like it. Ooh, I did like it. I don't like this. Although it's probably okay. Ah. Yeah. Alright, I guess I'm going to make this guy a little smaller. That'll do. I'll bring it down a little bit, actually. Nope. Alright. That's looking pretty good, if I do say so myself. It looks so much different than I envisioned in my head when I came up with the design. Oh no, I broke the shell. Ah! I broke the shell. How did I break the shell? Must have been in moving this stuff around. What if I... Will it tell me where it broke? Everywhere. It broke everywhere. I mean, maybe I go down like 1%, 8%, 0.11. Oh, 0.1. Haha! 0.1 worked. Alright, so I just made this thing deadly. Alright, I guess I'll run the FEA one more time, since I just made it whippier. I suspect it ain't going to change much. Ooh, but it did change that. It eliminated my move face on the dangerous region. See if I can restore that. This is a long ass video, eh? It's because it's right on there. So if I just move this ellipse just a smidgen of a pigeon, I don't even know what that means. I'm just loopy because I'm starving. Marvin, is that fixed? No. Ah. Why is that? Let's try to move it too far. .01. Reduce distance. Huh. Weird. Oh. Offset. Why was it ever offset? I want to translate. Why was it ever offset? 0.05. Done. What? Oh. What? Okay. That's incorrect. Wow. I'm not sure what. Oh. Maybe if I add this, we'll make it happy. No. If I add that. No. Wow, that's freaking goofy. One thing, I changed the shell, and then I changed something else. And can I go back to 1.12? Nice. I mean, that doesn't say fix this. I don't quite get what's happening there. Oh, now I do. How about now? Maybe? Nice. Little tricky things like that comes with experience. And you know, hopefully you gain this experience watching me do this. 0.05. Alright. Very nice. And I don't know what edge that's missing. Ah, okay, it'll tell me. I mean, I could go through here and add a bunch of radii. Kind of unnecessary. just putting in a few more radii. It'll help to make for a slightly stronger part. Tough to quantify, but in my experience, it's like chicken soup. Can't hurt. Although, you could argue the chicken soup can hurt because it's going to stop you from eating something more beneficial. So there. What? I don't know what happened right there. Oh, I do know. I know what happened because I'm in a section. I couldn't quite see that I already had that edge selected. That's just not necessary. That's not necessary. What? I'm not sure what's going on in there, but I'm not going to get hung up on that. Okay. Radius. Nice. Alright, we are looking pretty damn good. I'm going to delete this guy. I think it's long since it's been used. Same with this guy. That's my divide and conquer. I can delete that. And it's sketch. And what is this sketch? Oh, that's actually driving this direction. Okay. Okay. Let's get out of the section. Let's run the FEA one more time just to make sure I didn't accidentally wreck stuff. Yeah, this is pretty cool. I think this is just a little too close to this because I get that little crease right there and I get rid of all the rest of them, so I might as well fix this one while I'm starving to death. Already. Nice. Alright. This is a little sketchy here though. I kind of put this as, but this is already plenty of strength. But this and this are both putting the layers in shear. But most of the load, well, I say that it is distributed across these two. Let's run it again and see what it looks like. Magic failed. Well, I don't care. I ran this analysis enough times that I am very confident that, and I did put that shell back to 0.12, right? I believe I did. The shell, 0.12, yes, the shell is 0.12. So even though the mesh is not happy, I am done manipulating this thing. What is this little doodad? Alright, now I'm done. And I need to get rid of this guy. Ah, isn't that special? I was afraid of that. But it is so inconsequential that I don't even care, especially because it's on the first layer. So we're going to print it like this. I think everything will print just about perfectly. Ooh. Oh yeah, I did that at 45 degrees, so it wouldn't be an issue. Alright, don't use this part if not polycarbonate. Oh, I was thinking if I increase this radius here, it might make this whole region stronger. I'm not going to redo the analysis, but if I can increase this, without causing myself any other heartburn. There we go. Right to before that. Whoa. A little bit of lag on this instant 3D stuff sometimes, but that's okay. Still very convenient. Nailed it. Alright. Looking good. See. Oh, I broke my face. No. So much for that. I mean, at what point do I get my move face back? Okay. It's 0.1, it's back. .19, it's gone again. Well, so much for that. I don't know, I'm going to call it good enough. There we go. Okay. Improved it a little bit. Made it a little bit more. Alright. And, oh, I need a left and a right. So let's, I want them separate files, though. Alright, so I go, so when I save, oh, I can actually do step files now instead of STL files, which is nice for smoother printing in theory. So I'm going to go step file, and I always do a date code, so it's 0909. Oh, and it just happens to be, I'm not even going to say it. Okay. Yeah. 0909. And then I'm going to do a mirror. I know that face is square to something, so I'll mirror across that. Features, mirror, bodies, this guy, don't merge, I don't care about visual, and then delete this guy. I did a keep. Save as step file, copy that, OH, opposite hand, barbell hooks. Alright, so now I have my two barbell hooks, and I will go into Creality Print Slicer and slice these up and print them up. Stay tuned for the printing portion. Pardon me. Stay tuned for the printing portion of the series. And if you stuck around this long, preferably you can like and subscribe. Thanks for watching. And just a bit of an update. I had a realization that I forgot about making clearance for the upper side screw. And so I revisited looking at that, and I realized that I had a whole bunch of material in here that was not going to cooperate with that screw. So I modified the design a bit. Same basic design. Just sort of got rid of the material in here. And then after that, so this is set up for the FEA. And then I went and I ran the FEA. And I basically, this was 1 inch wide. And now this is 2 inches wide. And that really distributed the loads. And so my peak stress was, let's run, actually I think I could just hit this and I'll show it. And so my peak stress over here was like 4,800, just in, just as the artifact. But doubling the length of it brought it down to 1.9 KSI. And that's at the artifact, at the edge of the edge, right? And so not even a real stress. So the stresses around it are probably much more real, and those are for the most part under, well under 1,500 mostly. So this the dark blue is, into the dark blue is like 1,000, so like 1,200 psi. And so that should probably be fine relative to my other considerations. So this is the part that I'm going to print, and this, I chopped that guy off. That's just the FEA thing. Oh, and this, there's one, this guy I suppress. So I got, that was giving me a hassle for the shelling. And so I cut it off, and now I put it back on. So I think we're shelled. And we're not shelled. Why are we not shelled? Oh, because the shell... Yeah, that's right. So the shell, this feature breaks the shell. And let me just confirm that before I make that assumption. So now I believe the shell is in effect. If I do a section, yeah. So now I have the shell. So so the only thing is I can't just print it with already shelled, right? Which is no big deal, because in 3D printing you define the shells anyway. So not a big deal. And actually maybe come out a little stronger because there'll be a little bit of infill in there. So let me suppress that again. And so I guess that'll do it for this portion of the video. And next I will print both left and right hand versions of these, and that'll be polycarbonate, and then I will test them and see how they do holding my barbell out of head bonking range. I'm looking forward to that. So stay tuned. Thanks for watching. So I decided I might as well record the slicing. And so, where did I even save this? First I want to go to step files. And, okay, all right here. And I'm going to open both of these. And, it's funny how you always lose track of, or not always. It's so easy to lose track of the size of something. When you're in CAD, everything always looks the same size. You build a skyscraper or a grain of rice, and they always look the same size on your CAD. But little sticker shock on the size of these, but that's fine. Let's put them flat side down. Okay. And a little rearrangement here. And it looks like we're not interfering. Okay, so where do I have my polycarbonate? PC in MNG material. If only I remember what MNG material was, because I don't. PC normal. I'm going to say that must be the settings that work for me. And let's take a look-see and see what it says. 20. Looks good. Alright, now wall line count. I want to go. I want it to be 120. So, what's it? What am I saying? 120 thousandths. That is 3 millimeters. And so, if they're 0.4 millimeters, that would be 8 shells. Would be a little bit over. So let's be conservative and say 8 shells. Well, I go 8. And the top and bottom layers, so if that's 0.2 instead of 0.4, I'm basically going to double those. So I'm going to say top 16, bottom 16. And I don't think I'm worried about any of the rest of that. Infill 15, that's okay. Speeds. Ooh, was I really printing that fast in polycarbonate? That seems maybe incorrect. I'll have to think about that a bit. No sports. This is not polycarbonate settings. Well, I mean, this would, yeah. This would need to be. So I think my speeds are off. So let's say save just because, and I'm not sure what that all is. And if I go generic pet G. Let's go down to the end here. TPU, PLA, nylon, PLA. Oh, no, nylon. New HQ2. Okay, so that must be for pet G. I'm really not a big fan of how these are arranged. Like you try to go to another category and it still just shows all of your custom ones. PC normal, obviously not, evidently not the correct one. And that's it. If only I knew. Okay. Let's see if I have any G codes saved locally. G code archive. Probably not what I'm looking for in here, but let's see. 0807. Actually, maybe not. That may actually be the one I'm looking for. PC 3D Benchy. Open with. I don't know why it's not showing me Notepad++. Okay, here we go. Edit Notepad++. And we'll find just to get me in the neighborhood. Print temperature 300. looking for speeds. Travel speed. There we go. 222. Okay, that looks much more like it. Initial layer speed 33. Interesting. Okay. Well, let's do that. For whatever reason, these are not the right numbers. I mean, it's not even PETG numbers. 300, 300, 100. Outer wall flow. I don't know why I would want that 95. Let's go back up to here. Wall count. Didn't I just went through this and hit save. Did I not? No wonder why it prints wrong half the time. So if I do this, let's see. If I say save, and then I go back in here. Okay. Okay, 8 hours and 57 minutes. Well, so thanks for watching this extensively long duration video. I hope you enjoyed it, and hope you're inspired to share it and hit the thumbs up and potentially subscribe, and however to help other people to find my content if you find it of value. In any case, just a quick heads up so you can see here, this is the actual printing in action. This is live on my channel as of this recording, although obviously this recording is not live, so that video is not live, but you could probably find it on my channel if you're curious to see it printing out. That's if it succeeds. And I say that because this spool of polycarbonate is quite, I almost want to say it's haunted. So a couple issues with the spool. One, it entirely on its own jumped off of a table at some point, or off a shelf I should say, and broke the flange. Now obviously it was my own fault for not securing it properly, but it fell and broke the flange, and so that likes to cause tangles. I've experimented with various mitigations with mixed success, and so this is I definitely already tried this print a few times, and tried something a little different this time. And then the other problem with the spool of filament, and I'm not sure why, but man, this polycarbonate filament on the spool, it's just dying to unwind itself. Like if you just hold the spool in your hand and let go of the end of the filament, it'll unwind like a dozen turns on the spool, and it just wants to be straight. It's like this filament just wants so bad to be straight, and it seems like almost no matter what I do, it just unravels like crazy and then tangles around whatever it's attached to. So on this attempt though, I put it on the rear spool holder as the printer is designed for, and I sort of wound it back tight so the filament is really on the spool and needs to pull itself off. Now hopefully there's actually, like, so if there was no friction on that spool to turn, I'm confident that this thing would just unwind itself until it was a big, 3/4 kilogram pile of spaghetti. I say 3/4 because it's been used quite a bit already. But so hopefully the spool holder on the back of the printer has enough friction to keep it from unwinding. And then what else I did is I sort of bent out the I feel like I need to sneeze. It's funny, I've only been sneezing when I'm recording lately. Where you put the filament into the Teflon tube at the filament runout sensor on the back of the K1. So what I did is I bent that piece of Teflon tube outward a little bit, like further backwards, And so I'm hoping that that will sort of keep its shape and sort of guide the filament away from jumping the spool flange, because that's one of the problems, is that with the broken spool on this spool having half of one side of the flange broken off, and it happens to be the side of the flange on the printer side, meaning if that's not obvious, well, I'm seeing a weird artifact on my screen here, like a shadow. See this shadow line? That must be because I'm looking through the printer cover, and maybe that's reflecting off of the ceiling of the enclosure or something. I don't know. That's weird. But anyway, so so one of the two flanges on the filament is like half of it is completely broken off. So it's got like half of a flange on one side, full flange on one side, half flange on the other side. And unfortunately, the way you orient the filament on the spool holder is so that the filament is paying out upwardly on the right side. Does that make sense the way I said that? So it goes out. So if I'm looking from the front, it's paying out in a counterclockwise direction, and then the filament going straight up into the runout sensor at 3 o'clock on the clock, right? And so in that orientation, the flange that's broken on the spool is the flange that's up against the printer. And so that is part of my problem, is that it can get tangled on that broken flange. So I bent out the Teflon tube a fair amount, hoping that that sort of guides the filament to stay in the middle of the spool, or at least away from the broken flange. And so far so good. After a few tries with this is definitely the furthest it's gotten. And now I'm conditioned to be paranoid now that is it extruding still? Can I tell? But it looks clean. I think that's sort of the way to tell, is that the top surface looks pretty clean, whereas once it starts tangling, it tends to sort of look under extruded. And then, of course, 10 layers later, when it had stopped extruding 10 layers ago, you could sort of see this bit of fuzziness on the top layer, and that's sort of a giveaway. Whereas this top layer still seems very clean and solid, so that hints to me that it is likely still extruding properly. I see the little spider webbing up in the top center here. Not sure what's going on there. That sort of is what's making me paranoid that something happened, that it's failed potentially. But I think that's probably just been there for a while, and if I could rewind this, I could probably tell. Or I could just go out to my print shed, but that's a little ways away. And it looks to me, I'm confident enough that I'm not going to go check it right now. Maybe I'll go check it in a little while. You can kind of tell once it missed a whole bunch of layers, you can sort of see that the print head seems to be a lot higher than the top layer. But in this case, I think it still looks like, to me, like the nozzle is still at the same height as the print. So hopefully that's the case, and hopefully this print's, it's like a 9-hour print estimated, so we have a long way to go. It's I don't know if it's like an hour in. Does this tell me? Yeah, it does not. I don't think it tells me. Okay, it says here, started streaming 86 minutes ago. So I'm an hour and a half into this print, and it's looking good, and I only have 7.5 hours to go. Good entertainment for a Sunday, though. Ooh, which reminds me, I should check if there's a MotoGP race on today. But in any case, thanks for watching. Hopefully this print comes out, and then I can try it out and see how it works. And I'll put that in another video. This is just the end of the compiled all the previous videos in the making of this. This was kind of a funny one because I designed the thing and put a lot of time into designing it a certain way and a lot of structural analysis on it, and iterated on the structural analysis, working out bugs in how I set up the analysis, and I think I got it to a good place. And then I realized that I didn't account for one of the bolted connections, the upper bolted connection that I alluded to at the beginning of the video. I sort of cheaped out. I was sort of lazy on the pre-modeling of the actual unit that the hook fits on to. I just sort of did a 2D representation, so I probably would have been better off taking the extra half hour to make a 3D representation of the entire region that I'm hanging this from, because what ended up happening is I realized that I didn't account for that one bolt, and I had a big interference, and so I had to adjust the design to clear that bolted connection, and basically obsoleted a fair amount of the work that I did, but I still included it in the video because I still used the same finite element model. That was still relevant. The finite element analysis model was still very relevant, and the overall design of it was still relevant. And just basically the cutouts, I changed the cutouts, and then I made the top hook twice as wide. But it was ultimately I would say 80 to 90% of what was included in that lengthy recording was still relevant, and so I kept it. And it was also a neat looking design. Had it worked, had it fit the equipment, it was a pretty cool design. It almost looked like generative design sort of shape, but I figured I would keep that because a lot of it was relevant, and just append the revised design, and then append the slice, and now just append this outro video. So that's all this segment is to tie it all together, and say thanks for watching, and I hope you enjoyed it, and maybe you could consider hitting thumbs up and subscribe and share and comment if you have any questions, if you have any requests. Always encouraged, and look forward to more interactions with all the viewers. And thanks for watching, and I hope to see you watching my stuff in the future.